Good evening to all. Today we are going to discuss the last topic of linear algebra, that is matrices, eigenvalues and eigenvectors. So in yesterday one problem I have given, the homogeneous equations regarding has trivial solution. That means equate determinant not equal to 0. I asked that I don't remember exactly k or p value, but please check that k not equal to minus 4 by 5, or just you check that this value is correct or not, because I confident that answer k not equal minus 4 by 5. Sometimes I may do also small mistakes, that is while simplifying, adding small multiplications, all these things you please check later. Okay, now I am going to start eigenvalues and eigenvectors. So of all these three topics, that is basic level, the first day we have do. Yesterday system of linear equations along with rank of a matrix, and today we are going to eigenvalues, eigenvectors. The preference is, first preference that is problems given to eigenvalues, eigenvectors. Second preference rank, solving homogeneous, non-homogeneous equations, and the last one is third preference is basic level. Okay. Eigenvalues and eigenvectors. That is, I have written only one time eigen, that vectors means eigenvector only. Let A be a square matrix of order n, that is n rows, n columns, and lambda be a parameter, comma, then determinant a minus lambda I is equal to 0, just give an indication, underline, highlight, is called the characteristic equation and roots of this equation are called eigenvalues or characteristic roots or latent roots. Okay, here that a minus lambda I is called characteristic polynomial. Next, a non-zero vector capital X such that a minus lambda I into x is equal to O. That is, Ax is equal to lambda into x is called an eigenvector or characteristic vector or latent vector corresponding to the eigenvalue lambda of A. Now I am going to explain. A is a square matrix of order n, nothing to explain. Lambda is a parameter that depends on the matrix. Lambda changes real or complex parameter value. Then determinant A minus lambda I is equal to 0. A is the given matrix. Lambda, that is we are going to find, which is called a parameter, real or complex. I is the corresponding unit matrix. So how do you write this one? After writing this notation, how do you get that determinant? In the first step, lambda is multiplying with every element of the unit matrix and then subtracting from the given matrix A. So these are two steps to get this quantity inside the determinant. We are doing two steps, multiplying lambda with I and then subtracting from A. Instead of doing these two steps, I am giving the one step to get A minus lambda I directly. That is, subtract lambda from the diagonal elements of the given matrix A. Subtract lambda from the diagonal elements of the given matrix A. Okay. So later you check doing first lambda into I and then subtracting A. And what I told just now, subtract lambda from the diagonal elements of A. These two give same answer. After that, take determinant and equate to 0. Expand the determinant by the definition, which gives an equation in lambda. Maybe lambda square, lambda cube, so on. If it is a 2 by 2 matrix, that determinant gives lambda square equation. If it is a 3 by 3 matrix, that gives lambda cube equation. Okay, that equation is called characteristic equation. And if you solve that lambda equation, you will be getting values for lambda that are also called roots of the equation. That lambda values are called eigenvalues or characteristic roots, or other name is latent roots. It is a German word. Okay. Eigen is a German word. Okay. Here I am taking only determinant A minus lambda without 0. That gives characteristic polynomial. We know the difference between polynomial and equation. Okay. So expression is called polynomial. Expression is equal to 0. That gives an equation. Okay. Now this is the definition for eigenvector. This is so far it is, this line gives the definition of eigenvalue, how to find eigenvalues. Now this tells that, this definition tells that how to find eigenvector. Now see, a non-zero vector X. Vector means, I told you yesterday, it is either row or column. But the system of equations, we have solved so many problems that your X is nothing but column matrix only. Here also vector, eigenvector is in the representation of column only. Okay. A non-zero vector X such that A minus lambda I brackets indicates matrix. That lines, that standing lines indicates determinant. Now this is a matrix A minus lambda I into X is equal to 0. Now it looks like this expression looks like directly yesterday's homogeneous chapter. What is yesterday's homogeneous chapter? A into X equal to O. In that yesterday's X is nothing but column only, not a row. Here also X is nothing but column position only. Instead of A, what is the new letter here? A minus lambda I. What is the new thing here? A minus lambda I, which is also a matrix. Okay. So this simplifies to Ax is equal to lambda x. Okay. Depending on the question, the way to find eigenvector according to the options or without options, apply either this procedure or this procedure for finding eigenvector. Okay. That is a non-zero vector X such that this satisfies that X is called an eigenvector or characteristic vector or latent vector corresponding to the eigenvalue lambda of A. For example, if you get in 3 by 3 matrix, your lambda values 1, 2, 3. So for lambda is equal to 1, you will be getting some X, that non-zero vector X, that is called eigenvector. For lambda 2, for lambda 3 also. For every lambda, You have to get the corresponding a non-zero vector capital X satisfying this formula, this relation, that X, non-zero vector X is now called eigenvector or latent vector, other name is characteristic vector. So now onwards I am writing that instead of full word characteristic CH dot. I hope that you understand. Eigenvalue, instead of eigenvalue I am going to write E hyphen value, E dash value. Similarly E vector, like that. Okay, I hope that you understand that notations, all these things. So procedure for finding eigenvector, this one. Procedure for finding eigenvalues lambda, this one. Okay. Characteristic polynomial means don't take is equal to 0. Okay, once again I am telling that first step, subtract lambda from the diagonal elements of the given matrix and then take determinant, equate to 0, solve the equation, the value so obtained are called eigenvalues denoted by lambda. For every lambda there corresponds to a non-zero vector capital X satisfying this relation is called eigenvector. This is the procedure. Okay. So let me do a 3 by 3, 2 by 2 problem. After that properties like that. Okay. Just I compared, the notation changes here. Yesterday we have studied, that is we have learnt Ax equal to 0 homogeneous equation. In this homogeneous equation possess a non-zero solution. What I gave the condition? Determinant A is equal to 0. Instead of A, in this chapter the A is A minus lambda I. So this det A 0 becomes determinant A minus lambda is equal to 0. No change. I mean, concept is same, only the words and notation. Instead of A matrix, here we got A minus lambda I. Instead of non-zero solution, yesterday topic, now it is called non-zero vector. Vector means here column only. Okay, because we have studied yesterday X means column position only. There non-zero solution yesterday, today non-zero vector. That special name is eigenvector because of this notation, A minus lambda I. Okay. First example, find the eigenvalues eigenvectors of the matrix A is equal to 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. Solution. Write the question. Here I am going to find all eigenvalues and I will find one of the eigenvector for the corresponding eigenvalue. The same procedure adopted for other eigenvalues vectors. Okay, I will give the answers, later you check, because in exam it is asked only one of the eigenvectors for a 3 by 3 matrix. Whenever eigenvalue is mentioned, with mention or without mention, that eigenvalue, you have to find the corresponding eigenvector. Sometimes for a 2 by 2 matrix it takes less time compared to this 3 by 3 matrix. So that's why the questions ask to find all the eigenvectors in sometimes. Otherwise find one of the eigenvectors whenever the lambda is mentioned. Okay. Your first step is throughout this chapter CH equation. CH dot I already told you. Characteristic. EQ dot means equation is determinant A minus lambda I is equal to 0 implies determinant, what I told, subtract lambda from the diagonal elements. 8 minus lambda minus 6 2 minus 6 7 minus lambda minus 4 2 minus 4 3 minus lambda equal to 0. Just this is a 3 by 3 determinant. You know how to expand. Expanding by any row or any column gives unique answer. Go by first row. Expanding by first row. First element is 8 minus lambda into Okay, the cofactor of this one, plus into 7 minus lambda minus 3 minus lambda minus 4 into minus 4 plus 16, minus of minus 6 plus 6 into, that is determinant procedure, minus 6 into 3 minus lambda plus 8. Okay, next last one is plus 2 into 24 minus 2 into 7 minus lambda equal to 0. This implies, first always simplify that inside expression and then multiply with outside factor, and always write these terms in descending degree terms, highest lambda power and then lowest, next highest degree, like that. So here this simplifies to lambda square, 7 minus lambda, this is minus 3 lambda, total it gives minus 10 lambda, 7 into 3, 21 minus 16 plus 5. Okay, don't confuse, or whatever you know the procedure for simplifying, multiplying and then simplifying like terms, you do as you like. Okay, and this inside term simplifies to, the arrow indicates the simplification of that inside terms, 6 lambda minus 6 into 3 minus 18 plus 8 minus 10, and this simplifies to plus 2 lambda 24 minus 14 plus 10. Now each inside expression after simplified now multiplied with outside factor. So this going to first one, this simplification of this one implies minus lambda into lambda square minus lambda cube, 8 lambda square and this side 10 lambda square, total it gives 18 lambda square. 8 into minus 10 minus 80 lambda plus 5 into minus 5 lambda, that is minus 85 lambda. Numbers 8 into 5, 40. Next this one, 6 into 6 lambda, 36 lambda minus 60, and there 2 into 2 lambda, 4 lambda plus 20 equal to 0. Now like terms first of all simplify. Here highest degree is cube, lambda cube. Always you express before solving this equation the highest degree term coefficient is positive if possible. Okay, so because we are habituated in 6th and 7th standard solving equations with the first degree term coefficient is positive. Of course any negative also no problem, but we are habituated all solving with the first degree coefficient is positive. That means make the highest degree coefficient positive. That means we have to multiply both sides by minus symbol, right side 0, 0 into minus is 0. So this simplifies to how much? I am simplifying the like terms and changing the symbols because I told you multiplying both sides by minus symbol. Minus 18 lambda square and 36 plus 4, 40, after multiplying minus 40, plus 40 minus 85 minus 45, after that this becomes plus 45 lambda, and numbers constants 40, 20, 60 minus 60 all are cancelled, so this gives 0. We know from theory of equation 11th standard, whenever an equation is absent of constant term, then one root compulsory is 0, one of the root compulsory is 0. Whenever an equation is present of constant term, then no root is 0, all are non-zero roots. Here no constant term, so one lambda value 0, that is lambda is getting common, lambda square minus 18 lambda plus 45 is equal to 0, and this has factors, or you can find the roots for second degree equation every problem by quadratic equation method. Okay, now here 45 into 1, 45, minus 18 can be written as minus 3 minus 15, minus 3 into minus 15 is nothing but plus 45, so this is exact factorizable. So what are the factors for this? Lambda minus 3 into lambda minus 15. So all the three factors each is equated to 0, we will be getting lambda 0, 3, 15 are the eigen values of the given matrix A. Now the next step is I am going to find one of the eigenvectors, because all these three in this problem we got distinct. Distinct means different. Take it down. Now see, what is the matrix given here? Now I am finding eigenvector for one of these eigenvalues, that is first one 0, eigenvector for lambda is equal to 0. So what is the notation adopted for eigenvector capital X? That is should be non-zero. How to find that non-zero capital X? Used by the formula. What is the formula given for finding the non-zero vector capital X, which is called eigenvector? A minus lambda I multiplied with x is equal to 0. We don't know this x, we are going to find that x. What is the corresponding lambda? We have taken here 0. 0 into I is 0. A minus 0 is A. So this simplifies to A into x equal to O. What is A? Given matrix. 8 minus 6 2, minus 6 7 minus 4 2 minus 4 3. Suppose if after getting this answer you only do for other 2 3 comma 15 the corresponding x like this procedure. For example, if I take lambda 3, that means 3 into I. That means subtract 3 from the diagonal elements of the given matrix. You will be getting directly A minus 3i like that. Now into x, that is going to find, because it is a 3 by 3 matrix, x is nothing but your column position which we solved already yesterday. Complete equations. Your solution is capital X. Okay, we solved yesterday in both chapters, homogeneous as well as non-homogeneous. Here the name is non-zero vector capital X. We don't know, that's why I am taking x, y, z. For a 2 by 2 matrix, take x, y. For a 4 by 4 matrix, take 4 unknowns. Okay, finding that capital X is equal to 0, 0, 0, because 3 equations, 3 by 3 matrix. Convert this step. This is nothing but yesterday's chapter, homogeneous equations. Convert into equations. Don't find the rank, which will take a lot of time. Okay, because I will show you the procedure for finding eigenvector due to the time 1 minute, 2 minutes of your gate. Okay, and with options or without options, without yesterday's method finding the rank. Okay, I am showing the alternative procedure for finding x, y, z. Listen carefully. Convert into equations. 8x minus 6y plus 2z is equal to 0. So here 2 is getting common. Take that and then send into right side. So while writing these equations, you express if possible in simplest form. What is simplest form? If any symbol or any number getting common, send into right side, because each right side is 0. Okay, that is 4x minus 3y plus z is equal to 0. After taking common 2 and sending into right side. Okay, next second equation, minus 6x plus 7y minus 4z is equal to 0. Let us say equation 2. And third equation, 2x minus 4y plus 3z is equal to 0. Equation 3. Here 2, 3 are not simplified, no number is getting common, no symbol also. Now here we got 3 independent equations, that means 3 different equations. Okay, after simplest form or distinct equation. For understanding purpose only I am writing these words, not required to write. Take any 2 different equations, that is independent equations. Solve that x, y, z by the procedure just adopted using by cross multiplication method, which we have studied in solving 2 straight line equations in 2D in 11th standard. Okay, I will show you. Listen carefully. How to find x, y, z? Solving 1 and 2. Here we got 3 different equations. It is sufficient to get any 2 different equations after simplest form. Okay, then solving either 1, 2, 2, 3, 3, 1. If you get all different equations, take any 2 equations in these 3 unknowns problems. Okay, 3 by 3 matrix eigenvector problem. Now in the first equation, start with middle number and go on right side. That is, you know cycle, whenever you start, there only you end. There only you end. Whenever I start, cycle means anti-clockwise direction. Again come back to that position only. Here I am going to start in the first equation by considering the first number minus 3. Middle number I started. What is cycle? Completing one anti-clockwise direction till to get that position. Anti-clockwise means going to right side. Minus 3 after the z number is 1. And then there is no x. Here come back. That is x value 4. Again minus 3. So start at middle and same. End also. I mean starting and ending should be same. Then only this is called completing one cycle. Where we started here, middle term, y position, and then z position, and then x position. Again last is y. Starting y, ending y. Okay, anti-clockwise direction. That is completing one cycle. Similarly, that values from second equation. 7, including symbol also. Minus 4, minus 6, 7. 7, minus 4, minus 6, 7. Now, just for every 2 by 2 consecutive numbers, which is in the form of a 2 by 2 determinant AD minus BC. Each cross indicates a 2 by 2 determinant form. That value so obtained is called the respectively XYZ values. That is, first cross indicates first x, second cross value indicates y, third cross indicates z value. Each cross is in the form of 2 by 2 determinant. That means the procedure how to multiply that cross means, okay, to get that XYZ values. Okay, this implies x divided by first minus 3 into minus 4, 12, minus 7. It is in the form of just a 2 by 2 determinant A, B, C, D, AD minus BC. Similarly here is equal to, then put is equal to minus 6 plus 16 is equal to z divided by 28 minus 18. This simplifies to x by 5, y by 10, z by 10. Here also in all these steps of this chapter, you always express in simplest form. That is, if any number getting common, cancel. 5 1s, 5 2s, 5 2s. Okay. So therefore, eigenvector is first eigenvector. First lambda is 0. That's why the corresponding eigenvector, the notation I denoted by x1. Second vector x2. Third vector x3, like that. Is equal to, put that x, y, z values in the column form, which I shown you already yesterday. 1, 2, 2 into k. K not equal to 0. Why? Because if k 0, that becomes 0. But we are looking at non-zero vector. So that means for a single lambda, how many answers getting? Depending on giving 1 by 1 k value. Why should we give like that? Because this is yesterday's chapter, Ax equal to 0. Non-zero solution means how many non-zero solutions I gave in the definition? Infinite non-zero solution. Each non-zero solution in this chapter is called a non-zero vector. That is, special name is eigenvector. So that we conclude for a single lambda, that is eigenvalue, we have how many vectors? Infinite number of eigenvectors. Each is in the form of k into x. This is in the form of k into a vector. Okay? Right now. Generally, the options are in the form of writing the vector in the column form without k only. That means the people taking k is equal to 1. Okay. In particular, for k is equal to 1, we get the first eigenvector, that is for lambda is equal to 0, is 1, 2, 2. The options like in the form of direct numbers only without k value. That means give any one value to k depending on the options. But here I took in particular for k is equal to 1. Depending on the options, you choose k value, any one of the value. Okay. Now for other two eigenvalues, I am writing only first step and last step. That is last answer. Please check as above. Okay. That means apply the procedure as above. This is the important procedure. Okay. Now eigenvector for lambda is equal to 3. Your procedure is a minus lambda I into x is equal to O. Lambda stands for 3. Okay, subtract 3 from diagonal elements, that is 5 minus 6 2 minus 6 4 minus 4 2 minus 4 0 into x y z is equal to 0 0 0. So as above, in the first step I am giving x2 answer 2 1 minus 2. Later you check this is correct or not. Similarly, third one, eigenvector for lambda is equal to 15. Procedure is a minus lambda I into x equal to O. Lambda stands for 15. Subtract 15 from the diagonal elements, which gives minus 7 minus 6 2 minus 6 minus 8 minus 4 2 minus 4 minus 12 into x y z is equal to 0 0 0. So after simplifying in the first step, you will be getting the x3 eigenvector is 2 minus 2 1. Please check later at home. Okay, as above, the first step procedure. Now what we conclude, for a single eigenvalue our eigenvector is not unique. So if x is an eigenvector, then k into x is also eigenvector. I shown you in the first step. K into x, give any one number to value, give any one value to k, we get the corresponding eigenvector. Okay, but how many eigenvectors? Depending on giving the one by one k values only. Okay. And I shown you yesterday independent dependent also. Okay, give any one value to k, we get the corresponding linearly independent vector. One problem, second one, which is given 2013 2 marks. Find the eigenvectors of the matrix 0 minus 1 1 0, which is a 2 by 2 matrix, and this matrix satisfies skew symmetric also. Yesterday I told you, day before yesterday, and it is also orthogonal matrix. You check this one, both satisfying skew symmetric as well as orthogonal matrix. Solution. Characteristic equation is determinant a minus lambda I is equal to 0, which implies subtract lambda from the diagonal elements, which gives, and this simplifies to lambda square plus 1 is equal to 0, and this simplifies to lambda is equal to minus I comma I, plus 1 going to minus, that side minus 1, square going to square root. Before square root put plus or minus, and square, the number under square root is minus 1, square root minus 1 is imaginary I. Okay, sometimes options are also giving in the form of j notation, minus j comma j. So here also we got distinct two different eigenvalues. In some problems eigenvalue may repeat. Next, eigenvector for lambda is equal to minus I, or E values. E values means eigenvalues. Now what is the procedure for eigenvector? A minus lambda into capital I, that is unit matrix, into capital X equal to O. What is lambda here? Minus I. Minus of minus into I means plus I. That means earlier if it is minus, I told you subtract that element from the diagonal elements. Now in this case this becomes plus, so add that element to all the diagonal elements of the matrix A. So which simplifies to how much? Add I to all the diagonal elements of the given matrix. I minus 1, 1, I into, because of 2 by 2 matrix, the eigenvector is in the form of xy. Take two unknowns is equal to 0, 0. Will gives two equations. Ix minus y is equal to 0, equation 1, and x plus iy is equal to 0. Now we have to arrive at some condition in these two equations. Earlier in the problem, minimum two different equations we got for solving eigenvector after converting that into equations. Now here I already convert into equations. We got two equations. Let us check these two are coincident or different equations, that is distinct equations. See, it seems that both are different equations, but here these are not different equations I am showing. Okay, one can be written as Ix is equal to y. Okay, or Ix plus I square is into y is equal to 0, because I square value minus 1. Take I common, okay, and then send into right side. 0 by is 0. This is nothing but x plus iy is equal to 0. So that is, since I square is equal to minus 1. So what happened here? 1, 2 are coincident, same equations. Okay, that means we are finding here xy, the two equations same. That means right now we have only one equation. Please remember, in this 2 by 2 matrix, while finding eigenvector, the corresponding equations, the two equations must coincide. It is compulsory. You check any problem, the two equations must coincide while solving eigenvector for a 2 by 2 matrix. Okay, now how to find that xy values? So earlier I shown you 3 by 3 matrix, so that is eigenvectors, three equations solving any two different equations. Here not required that method. So anyhow, your last step of eigenvector, last but one step in expressing in the form of x by some number is equal to y by some number is equal to z by some number. But here two unknowns only, x and y. Okay, that means write this equation in the form of on each side containing only one unknown. Okay, now either 1 or 2. 1 implies Ix is equal to y. This can be written as x by 1 is equal to y by I. This is one representation. Or x divided by 1 upon I. That is, whenever the pre-multiplication to bring into the denominator, which becomes reciprocal of that number, this can be written as y by y. That is, 1 upon I is nothing but x by minus I, and this can be written as x by y is equal to minus 1. That means I sent minus 1 into that side. Okay, since 1 divided by I is nothing but minus I. Earlier that means this simplifies to minus I, that plus 1, but I multiplied both sides by minus symbol. Okay, so therefore eigenvector for lambda is equal to minus I is denoted by x1, which is first notation 1i. In the second notation you can write that is I into minus 1, because I told you whenever you get a column, k into that column is also an eigenvector, which I shown you previously. Due to that only here we got two representations. Similarly you can represent depending on the options, this is minus I and that is plus 1 also. Depending on the options only you express these equations where one side x, other side is y, the corresponding denominators depending on the options only. Okay, similarly we can find the eigenvector for lambda is equal to I as above. Okay, this procedure, make it